So our angle relationships, as just a review, remember when we talked about complementary angle relationships? Complementary angle relationships meant that you had the sum, which means that you were adding two or more angles, and it's going to have a sum that is equal to the 90. So for example, if this was x and this was y, we said that x plus the y was going to be equal to 90 degrees. Okay? And remember, when we take those relationships, when we're taking those angles, they basically together look like they're forming an L shape. Okay, they look like they're forming that 90-degree angle, but there's just a division between the angle itself. Okay, then we have our supplementary angles. So for our supplementary angle relationships, it also is a sum, and it's going to come out to equaling 180 degrees. So it forms that straight angle, that straight line is created there. So again, if this was x and this was y, all we stated is that when you add x and y together, the equation would be equal to 180 degrees. And then the last relationship that we had discussed was the vertical angle relationship. So remember, vertical angles are basically just congruent or equal to each other, and they are formed by these intersecting lines. So you basically have what looks like a couple of lines crossing over each other. And in this situation, if this was x and this was y, then what we're saying is that x is equal to y. You do not add them together. They do not equal a number. They are equal to each other. Okay, so that's just the basic idea of what we had covered from last week. So now we're going to use those ideas and kind of go a little bit more extensive into it with equations that are not just, oh, this was x and this is 70, so x is equal to 70. It's now you got an equation involved with it, or you've got multi-steps that are involved with it. That's what we're going to basically be looking at. So you want to make sure that when you're looking at your angles, you identify the relationship first so that you know whether you are setting it equal to 90, setting it equal to 180, or setting it equal to each other. So what relationship is being displayed here for problem number 1? Io? Vertical angles. Okay, so again, we've got those intersecting lines. So what that means is that these angles that are directly across from each other are going to be set equal to each other. So this is a vertical relationship. So we are setting 2x to be equal to 70. And then from there, we can go ahead and solve that equation. In order to solve, all we have to do is divide both sides by 2. And we'll get x is equal to 35 degrees. Okay. Same concept or same idea again for problem number 2. Again, what type of angles are these? They're vertical, right? They are formed by those intersecting lines, and they are directly across from each other. They are not side by side. Remember, side by side means they are adjacent. They share something in common. Okay, share a common wall. These are vertical. They are directly across from each other. That means that they are going to be equal to each other. So we would set up the equation to solve. So we would state that 3x minus 1 is going to be equal to 155. So this one's a little bit more extensive than what we had from the first one. So there's a two-step process. Who remembers what is the first inverse operation that we need to perform? Carol? You add 1. So we're going to go ahead and add 1 to both sides. That's going to give us 3x is now equal to 156. And then our last step would be to what? Divide by 3, right? Okay, so once we divide by 3, we would get that x is equal to 52 degrees. Okay, once you've got that written down, go ahead and flip it on over to the back. Okay, what I want you guys to do from here is the very first couple questions that I'm giving to you, you're just identifying whether it's complementary, supplementary, or neither. Okay, it doesn't have to be complementary or supplementary. If they don't add up to 90, if they don't add up to 180, then they have no relationship in that sense. So So you're going to identify complementary, supplementary, or neither based off of their additions. And then again, you're going to take those rules that we had with complementary, supplementary, and vertical. You're going to identify the relationships that you see here, and then you're going to solve for the missing values. Please note that problem number 3 does have an x and a y that you are solving for separately. So go ahead and work that out. Okay, so for problem number 1, is this going to be complementary, supplementary, or neither?
Supplementary.
Huh?
I'm supplementary.
Supplementary, right? If we were to add those together, if we take that 53 and we add it with 127, that is going to equal 180. So since it equals 180, that's going to make it supplementary, because supplementary relationships are going to add up to equaling 180. What about number 2? Complementary, right? If we take that 56 and we add it with the 34, that is going to be equal to 90. 90 degrees is going to come out to being complementary. Okay, again, complementary is not a single angle that equals 90. It is multiple angles combined together that are going to add up to 90. What about problem number 3? Neither, right? They are absolutely neither relationship. If we add the 30 and the 39 together, that's going to be equal to 69. That is neither complementary nor supplementary. Okay, it has to equal either 180 or it has to equal 90 in order to have one of those relationships. All right, so let's take a look at problems 1 through 5. We're going to identify the relationships, set up the equation, and solve. So what relationship is problem number 1? Io?
22.
Okay.
Complementary.
Thank you for solving, but yes, complementary. It is going to be complementary, and yes, you are right. It is going to equal 22 degrees. This is a simple one. Okay, this is kind of similar to what you guys were working on from last week, where all we're going to do is take the value of x and add it with 68 and set it equal to 90. And then from there, we just have to go ahead and solve. So we would subtract 68 from both sides and get that x is going to be equal to 22 degrees. Okay, problem number 2, the relationship that is involved in problem number 2. Mackenzie? Supplementary, right? So that means that when we combine those together, it is going to be equal to 180 degrees. Tree, sorry, misspellings. Okay, so we take 2x, we add it with 36, and that's going to be equal to 180. So we're taking those two angles, 2x and the 36, combine them together, it equals 180 degrees. We're going to go ahead and solve that two-step equation by first subtracting 36 from both sides, boys. That would leave us with 2x is now equal to 144. And then we would divide both sides by 2. And we would get x is equal to 72. Okay. For problem number 3, we actually have 2 different relationships that exist here. So whenever you have a variable as an angle, and then you have angles that have no variable, you want to see how that variable angle relates to the non-variable angle. So here's what I mean. I have a 2x and I have a 120. So I'm going to hide everything else. I'm going to hide everything else, and I'm going to ask myself, how do 2x and 120 relate to each other? What relationship does 2x and 120 have? What relationship is that? Is this complementary? Is it supplementary? Is it vertical? Which one is it? Supplementary, right? When we're looking at them together, guys, some of you are way too quiet and you gotta start answering. When you look at them together, they are going to form a supplementary relationship. When you look at them together, they are going to form a supplementary relationship. Okay, so for here, I'm going to write down 2x and 120 are supplementary. So that way I know how I'm going to set up my equation for them. The 2x and the 120, that is a supplementary relationship. So that means I'm going to take 2x, I'm going to add it with 120, and that's going to be equal to 180 degrees. From there, I can start solving. God bless you, I can subtract 120 from both sides first. That's going to leave me with 2x is now equal to 60. And then I can divide both sides by 2 and get x is equal to 30. Okay, so I have the value of x. Now I still need to go in and solve for y. So again, I want to look and see how are the y and 120 related. So I'm going to cover up that 2x. I'm going to pretend that 2x doesn't exist at all, and this is my diagram. What relationship does this diagram present? What relationship is it going to be, Corbin? What relationship do I have here? Okay, so what relationship is that called? Vertical. So we have a vertical angle relationship presented here. So again, when that 2x is covered up, these angles are forming that cross, okay, that intersecting lines. That means that they are vertical to each other. So I'm going to write that down, that 3y plus 30 and 120 are vertical. Those are going to be vertical angles. So that means I'm going to select 3y plus 30 is equal to 120 when I set up my equation. From here, I would subtract 30 degrees from both sides. That's going to give me 3y is now equal to 90. And then I would divide both sides by 3 and get that y is going to be equal to 30 degrees as well. Okay, you have to identify your relationships, and a lot of times you're going to be presented with angles like this in which you do need to solve using different relationships. Okay, we're going to pause here for a moment. Okay, taking a look here for problem number 4, what relationship does problem number 4 present to us? Thank you, Ariana, complimentary. Okay, it is forming that L shape, and it does have that symbol that indicates that it is a right angle inside of it. So that means that these two angles combined together are forming a complementary angle relationship. So make sure that you're identifying the relationship as complementary. And then when we set up the equation, we are just combining them together. Typically speaking, I always advise that you write your variable equation or your variable angle first. So that would be the 6x plus 10. I'm going to write that first. And then I'm going to add that angle with the 20-degree angle. And it should be equal to 90 degrees. So in a situation like this, the first thing that you need to do is combine your like terms. So we have the plus 10 and the plus 20 that we can combine together. So we're going to combine like terms first. Okay, so if I add 10 and 20 degrees together, that's going to give me that 30 degrees. So we now get 6x plus 30, because it's a positive 30 that we're getting, and it's set equal to 90. From there, we can then go ahead and start solving. We've simplified as much as we can. We can then start solving by subtracting 30 from both sides. That's going to leave us with 6x is now equal to 60. And then we can divide both sides by 6. And we'll get x is equal to 10. Okay, for our last relationship that we see here, what relationship is that going to be? Isaac? Huh? No, they are a relationship. So what relationship, Io? Supplementary. Okay, when we're taking a look, combining these two angles together, if I take this 4x plus minus 50 and I combine it with the 70, it's creating that straight line. That straight line means that it is a supplementary angle relationship. It is going to be a supplementary angle pairing. Okay, so what that means is I'm going to take 4x minus the 50, and I'm going to add it with the next angle, the 70, and it's going to be set equal to 180. Okay, and again, just like we said before, you combine your like terms. So we have a minus 50 and a plus 70 that's going to get combined together, right? We're combining like terms, CLT, combine those like terms. When we combine a negative 50 and a positive 70 with each other, it comes out to a positive 20. Okay, that 4x is going to come straight down into our equation. 4x plus 20 is now equal to 180, and then we can go ahead and solve. We can subtract 20 from both sides. That gives us 4x is now equal to 160, and then we would divide both sides by 4 and get x is equal to 40. Okay, you need to make sure you understand your relationships. Identify those relationships before you start solving. Okay, don't forget how we work through solving equations. Combining those like terms is really important to do before you start solving. Okay, your activity for today is going to be a IXL skill.